So some of the people will be removed from the call automatically. If you can see my screen, right? Please join back. Sometimes few email IDs have some issue, so it automatically kicks them out, right? I don't know why. So I think it's Amal Prasad, you'll be kicked out, but please you can join back from other email ID. Okay, so the recording has started. Welcome everyone to this session on asynchronous programming. Before I start, as I mentioned, this is going to be a little bit advanced concept. It will be, and you'll have to pay a lot of attention. It's not that easy to grasp the whole concept. I will try my best to explain you. This is going to be a very conceptual. Of course, there will be some coding that I will be doing to explain you things, but try to understand the logic first rather than the syntax. Syntax you will learn with time, which I will explain. Okay, so before I start, how many of you know about asynchronous programming? Have you ever heard of asynchronous programming? How many? Put in chat box if you have heard, or if you have not heard, put in chat box. I would like to know. Okay, no, yes. Yes, can you please make the session interactive? I don't want to talk to all. No, no, no. Okay. So are there only 4 or 5 people? Okay, yes, I see some of the yes. No idea. Okay. Okay. Now let me tell you this. If you asynchronous programming is something no one teaches anywhere, right? And it is one of the most important thing when you will write codes for your uh, company. It could be your data engineering role, it could be your machine learning role, it could be your software engineering role. Very, very, very useful in Gen AI software development. Everywhere you will see async, right? I mean, like it's a very standard code. I'm not sure if you have seen. Let me show you a very simple example. uh, if you run, if you see this particular code which I'm showing you right now, you see, you would have seen this asyncio, right? And you would have seen async functions, right? So these are you have to convert all your code into async before you move into production your code. So what happens, if you know, in any company there are 3 environments: one is development, one is testing, one is production, right? And wherever you have to make your software live to public, because a lot of people use your website, use your services, right? So you have to make sure your performance is good, and a lot of those things there asynchronous comes very handy, and that is why you need it. So in almost every software code, if you go online, check it, everywhere you will see this particular thing async. Like you will see this asyncio and async. How many of you have seen this? First tell me this. Don't believe in what I'm saying. How many of you have seen something like this? Async. Have you guys seen this like ever, anywhere? Is my voice too low? Yeah, it is very much used in agentic AI where it is used. Like for example, let me show you this thing. Like if I open the LangGraph documentation, right? Let's go here. Let's, even if I open this MCP, right? It will be everywhere. MCP. I'm just taking an example. If you see this here, you will see uh, await, right? Await is basically async IO only. So we will study what is await. What does it do? Similarly, in a lot of codes, you will. Uh, Let me show you this as well. For example, let us say I talk about streaming, right? Here you will see an option of sync async. Okay, sync is regular that you do, but sync codes are not scalable. Their performance is not good, and I will show you with example why their performance is not good and why do you need to learn async programming. Okay, so this is just a basic idea, but let's start with the intuition first. right? Forget about asynchronous programming or anything else. Let's try to see a very, very basic example, and then from there we will take up and we will move towards the coding part. Okay. So let us assume what you're doing, you are in a restaurant. Okay. So you're in a restaurant now. Suppose in a restaurant, what happens? There are some customers, right? So there's a customer A, customer B, customer C. Okay, and all of them basically they need to have some food. So for example, let us say one wants, sorry, one wants to eat pizza. Okay, and other guy wants to eat maybe. So one wants pizza and other wants burger, and let's say other wants pasta, for example. And the third person wants pasta. Okay. Now, suppose there is only one waiter in this particular restaurant, and to basically prepare a pizza, it takes, let's say, for example, let's say it takes 5 minutes. Okay. And to prepare a burger, it takes 3 minutes. And to prepare pasta, it takes, for example, 2 minutes. Okay. Now, suppose there are 3 customers sitting here. So let's say there is a customer here, customer A. And then there is customer B. So let's do this. This is customer A, this is customer B, and this is customer C. Okay. Now, let us say there is a waiter. Okay. Basically, for example, let's say there is a waiter here. Okay. Waiter. Just a moment. Okay. Let's say this is a waiter, for example. Okay. Let's say he comes to take the order. Okay. And he takes to the kitchen. Now, suppose, so let's say this is the waiter. Now, this person, for example, let us say he orders pizza. Okay. And this person orders burger B, and this person C orders pasta. Okay. Now, right now, there's nothing related to programming. I'm talking a very general scenario. Now, suppose this waiter comes, it takes the order from this, then it takes from this, so it has to take order from A first, then B first, then C first. Okay. So suppose he comes here, he takes the order from him and takes to the kitchen. Okay. So how much time will it take to deliver him the dish?
5 minutes.
5 minutes, right? So he will come here, he'll take the order from it, go get it prepared, and bring him 5 minutes. In those 5 minutes, person B and C are waiting. Has anyone taken their order? Imagine yourself, you go to a restaurant, right? And what is happening that first of all, the waiter, so think like this, waiter comes, what is the task? So let's say this is a waiter and there is a cook in the back end. Okay. Let's say there are multiple cooks who are in the back end. Okay. Now, what is the objective of waiter? What is his goal?
To take all the orders, to deliver all the orders, and
Take
keep the
the order
customer
and
happy.
deliver all the order, correct? So now suppose this particular person comes here, takes the order, gives the order to the cook, and he keeps on waiting till the food is being prepared. And once the food prepares, then he comes and delivers to person A. Is that a right approach or a bad approach?
Bad approach because other customers are waiting B and C.
Right? So other customers, so in restaurant does not happen, right? You go, let's say 40 people are waiting, 40 people are ahead of you, and let's say each person food takes 5 minutes. So 40 into 5, 200 minutes. You're not going to wait for 3 hours in a restaurant, right? So what should this waiter ideally do?
Take others' order as well.
Simultaneous order.
So he should come here, this particular waiter should come here, take the order from pizza, from A, go tell cook, now come to person B, take the order, give him, now come to this person and give. So let's build 2 scenarios, okay? So in the first scenario, when we were talking about, okay, so scenario 1, if I talk, how much time will it take to do the complete order of all 3 people? 5 plus 3 plus 2, correct? 10 minutes. Yes or no?
Yes.
Whereas in second scenario, what I'm saying, let's say the time that waiter comes, takes the order and goes to the cook is 0 seconds. It's like negligible, for example. Okay. So waiter came here, took the order, gave to him. Cook started preparing, right? At that moment only, from 0 seconds. Now, it came here, took this order, gave to him, took this order, gave to him. Now let's study the timeline. Okay. So for example, let us say, if I try to study the timeline here, 0, 1, or maybe let's do it in Excel. It will be a little easy there. Okay. So for example, the same scenario, let's try to visualize here that what is going to happen. Let's say this is second 0, 1, sorry. Okay. Okay. So right now, let's say this is the timeline. Okay. Now, assume, as I mentioned, for the waiter 1, for the waiter to take order and go back to cook is negligible, or let us say it is 0 seconds. It does not take that much time for him to. Now, at 0 second, so let's say this is A, this is B. For example, let's say this is pizza, right? Customer A, customer B, and customer C. Okay. They are here, customer B and customer C. Now tell me the order. So at the 0 second, the person came, right? The waiter came, took the order, and it started preparation for him. Yes or no?
Yes.
Correct. So at second 1, so how many seconds will it take for the first person for order to get created? 5 seconds, right? That's what we saw here. 5 seconds.
5 minutes, right?
Minutes, sorry, minutes, yeah. So it will take 5 minutes for this person's order to get created. Correct? Now, let's talk about customer B. At what time his order will start getting created? Okay, let's do one thing. Let's to make things more realistic. Let us say it takes 1 second for waiter to please mute if you are not speaking. Let's say it takes 1 second for waiter to take the order and deliver to the cook and further deliver to the person again. Okay. So for customer A, so when time will start, 1 second will go where? Can I say that 1 second it will just be taking the food, taking the order and delivering and giving to the waiter? Sorry, giving to the cook. Can I say that? In 1 minute. Guys, yes, no, maybe tell me please.
Yes.
Yes.
In the first minute, the waiter will come, take the order from A and go to the cook. And in next 5 seconds, it will take, the cook will prepare the food. And in the last minute, basically, he will deliver the food. Yes?
Yes.
Clear so far? Now, tell me suppose after 1 second, when the waiter has taken the order and given to the food, is the waiter free or not?
It's free.
It is free. So can you take the order from B?
Yeah.
So waiter will come and take the order from B, and it takes 1 minute to take order, and for B it takes 3 seconds to prepare. So let's say these 3 seconds it take to prepare. Okay, so let us say it took these 3 seconds to prepare the food B, and 1 second again to deliver the food back to him. Clear? Now let's talk about customer C. It takes 2 minutes to prepare the pasta. At what second will he take the order from the customer C?
Third second.
Third second, right? So third second, it will take the order. 2 seconds, it will need to prepare. So the cook will need to prepare. So for example, let's say 2 seconds it took, and 1 second it will take to deliver him back. So at what time do you see all the 3 orders being finished?
7th minute.
So if I say in the 7th minute, by 7th minute, all the orders have been delivered. Yes?
Yeah.
But if it was a regular thing in the first scenario that we were talking about, how much time would it have taken there? Let's see that. It would have taken so think like this. First minute, it will go to the customer A, take the order, 5 minutes to prepare and 1 minute to deliver. And when will the task start for the customer B?
8th minute.
8th minute, right? 8th minute it will start, and then it will take how many seconds? Let's say 3 seconds to basically do this, and then 1 minute again to deliver it. So I will have to extend it. 11, 12. And now for customer C, when it will start?
13th second.
13th minute, it will start the order. 2 minutes, it will take time to prepare. Okay. And 1 minute, it will take. So 12, 16 minutes it took to deliver in the second method, and in first, how much time did it take? 7 seconds to deliver the food. This is the concept of asynchronous and synchronous programming. Whatever you are seeing at below is called synchronous. That what does it mean? That you wait for one task to get completely over. So you wait for this task to get completely over, then only you will start executing the task 2. And once the task 2 gets completed, then only you will start the task 3. Clear?
Clear.
And what do we do in asynchronous programming?
Parallel work.
It's not parallel. Remember, this asynchronous programming is not parallel. That is a very common misconception. It's not actually parallel. I will tell you. But if you see, things are happening. So at the same time, here, if you see in the second scenario, waiter is free for these 5 seconds. Waiter is free here. Waiter is free here. In the first scenario, is waiter free at any point of time? Apart from when food is preparing.
No.
It's not free, right? The moment he gets free, if there is any task, he will start doing it. Here he cannot do anything because food is already being prepared. He cannot do anything. So he might be sitting idle. But the moment there is a task that a food is prepared, a customer is waiting, he will go and do the task. Now, this is the intuition of asynchronous programming, which I will bring to the coding as well right now. Tell me guys if you have any doubt, please, in this. So what do you understand from this? Tell me.
Why it is not parallel? Because the waiters are taking the parallel orders from customers. There is only one secretary for that.
Sorry, I didn't get you.
Why that is not parallel?
Parallel is when all the tasks start from the same time. The tasks are starting at different time. This started at first second, this started at second second, this started at third second. Parallel is called when everything started at the same time.
Also, it is not parallel because the waiter is not cooking the food. It is the cook who is cooking the food,
Yeah,
and waiter is just taking another order. He is not doing anything at that time.
right. So this is not parallel. What do you mean by parallel? Tell me. Parallel means
All at once.
when things start at the same time and finish at the same time. This is not that. This is starting at first second, this is at second second, this is at third second or minute. So this is not parallel basically. Parallel is something, it's a separate concept. So it looks like parallel, but it is not parallel. Okay. Any other question, anyone? Before I move to the actual coding part.
No question.
Okay. So now let's study this particular thing in asynchronous. So there are three things: asynchronous, threading, and multiprocessing. What you say with parallel is called multiprocessing, which we will not be covering in today's call. Today we'll be covering asynchronous. So what is asynchronous programming we are going to cover. Okay. Now there are few concepts in this. There is a concept called as asyncio. This is a library in Python which comes pre-built with Python when you download Python. There is a concept of await, event loop, coroutine, create task, gather. So we are trying to focus. We'll try to understand what is coroutine. We'll try to understand what is an event loop, and then we will study asyncio and await. That how do they work, and how does what is the objective of asynchronous programming? Okay. So this is what we are going to study. Okay. But before that, let me show you a couple of examples. Okay. What exactly means. So if you see this here, I have why this is very important. First of all, now if you see, now you don't need to know what is web scraping and all that for now. Suppose you have to basically you have to download files. For example, let us say you have to download these two images. Okay, there is one image is there, one image is there, and let's say there are 100 images. Now one image takes 2 seconds to download. Okay, so if you have to download 100 images, how many seconds will it take?
200.
200, correct? One image take 2 seconds to download, and so 100 images will take 200 seconds. What if I tell you can download 100 images in 2 seconds only, or maximum 3 seconds? This is where async comes. So what it does that you can give multiple, let's say when you're now, where this is very handy, that's what I'm showing you a few examples. Suppose you're downloading few things, forget about the code right now, we'll be building this concept. But what happens that when you run this code, these two images, they will get downloaded like just a second. I used the incorrect one. This is not the right one. But into email. Email is not a package. Web script. Okay. For example, let us say, for example, let's take this web script example. Okay, you have three web URLs. You want to scrape them, right? Now, when you run it, there is something wrong with my system. Just a second. Okay. Anyways, I'll come to this again. That's fine. Okay. So let's do one thing. Let's do a very basic example. So we'll start this this particular thing. So terminal cd desktop empty. Okay. So now let's look at a few examples. I would say. So suppose, let us say you are preparing some food, maybe, right? So let me show you this. I say that, for example, import time. Okay. Now what I do here, I create a function, prepare a food. So let's say I say prepare. Okay. And I say order and delay. By order means what food you want to prepare, and delay means how much time does it take to prepare that particular food. Okay. So whenever this function, I do a print statement saying that preparing, and I'll mention this order, and let's say I give dot dot dot. Okay. So the preparation started, and let us say what happens that during this process, this particular code takes some time. So now I'm just simulating it. What I will do, I will say time dot sleep. Okay. So what it will do, it will basically stop my CPU for that particular delay time. So let's say it take 3 seconds. So it will stop the function for 3 seconds. And once it is done, I will say print f. I'll say order. Okay, order ready. Okay, so let's say this is a function. Okay, now what I do, I call this function in my main function. I'll create a main function of my code. I will say prepare. Okay, so let us say I want to prepare pizza first. So I will say pizza, and let us say it takes 5 minutes to prepare a pizza. Okay. Then second, I call this function again, and I call this function again. So let us say it takes how much time? Burger, and let us say pasta, for example. So for burger, let us say it takes 3 minutes. For it takes 1, for example. Okay. Now I run this main function. Let's see what will happen. When I run this main function, what is going to tell me what is going to happen?
So first say preparing pizza.
It will start with preparing pizza. It will take a
Sleep
5
for
second
5 seconds.
5-second break. Okay, and then it will say pizza ready. Then it will start saying. So first of all, it will execute this function, right? Then it
Yes.
will execute this function. Then it will execute this function. Correct. So let's see this. Preparing pizza. Okay. Pizza is ready. Now preparing burger. Pasta ready. Something like that is there. Okay. So now sleep, delay, order ready. Okay. Okay. So now, how much time did it take to prepare everything? It took 5 seconds here, took 3 seconds here, and took 2 seconds here. Yes or no?
Yes.
What if I tell you there is a better way to do this? Okay. And right now, don't worry about the syntax. Just see what I'm trying to do. Okay. So what I'm going to do, I'm going to say import asyncio. Okay. And I'll say is async. So I'll just copy this whole function. Async. Wait a second. Okay. So this is async def this, and then I will say the next function async def main. Okay. And here I will say await asyncio. Don't worry about the syntax right at this point of time. I'm telling again and again. Dot gather. Okay. And here I will call the function. So here, whatever I did here, for example, this prepare. Okay, I'll copy this. So prepare this, and prepare. I'll just give a comma. Okay, and now if I run this particular thing, asyncio dot run, and I give main. Now, when I will run this, what is going first? See what is first. Tell me whether it is fast or not. Okay, rest we will see later. I will explain you. Time is not defined. Okay, import time. Just a second. Yeah. Okay. Now, if I run this code, it is preparing pizza and preparing burger, preparing pasta. No, it should have taken. So it takes. Wait, let me just check if I've written it correctly.
If you give pizza less time and burger more time, then I think it would show like that.
Sorry.
If you give pizza less time than burger, so it is 3 and burger is 5, then I think the print statement would be different.
Let's see. No, something I have written incorrectly. I'm just checking it. Time async def this. Oh yeah, that is the reason. I have not given here await. That is the reason I was thinking. Await asyncio dot sleep. Okay, delay. Dot sleep. Now it will work. So let us say this was 531. Okay. Now if I run this code, see what do we see that now try to compare see the result and tell me what is the difference between both of them. So let's comment out this one first. Okay, let's this. If I run this, what is happening? First it is preparing pizza and then pizza ready, then preparing burger and then burger ready and then preparing pasta, then pasta ready. So can we say that it is going step by step? Unless this task is done, it is not starting this task. Yes or no?
Yes.
Yes.
Okay, that is why it is taking 5 plus 3, 8 plus 1, 9 seconds. But now see in the second scenario, what is happening. In the second scenario, if I run this, see, let it run first. Preparing pizza, preparing burger, prepare pasta. All three came at the first. All three preparation came first. What does it mean? That before pizza is prepared, it already started preparing burger. Yes or no?
Yes.
So, and overall, it took less time. Overall, it will take around 6 seconds because 5 seconds, so around 6 second max to max it will take. Okay. So, do you understand the difference between these two codes?
Yeah.
What? So now tell me, what is the advantage? What is the difference? First, think that intuitively. First, tell me that. What do you understand from this example? Before I move ahead.
I think it's fast in
You are,
processing.
you are asking for pros and cons?
Yeah.
The pros are like it's faster, it can uh, it can build application more robust, and cons like
How it can build application more robust?
It will take input-output operations based upon the time, and it will give back manage input-output operation.
Okay. Anyone else? Any other point?
Yeah, if there is no dependency, we can go with the async one. If there is dependency, like if pizza after the pizza page is downloaded, then only we can do the burger. Then this async one will not work.
Yeah. So first of all, let's try to understand when is this scenario. Like when do we use async? So we have to use async and all that in cases which involve IO operations. What is IO? What do you mean by IO operations?
Input-output.
Output operations. Okay. So what are such operations? Can you give me an example? When you do API call, okay. So think like this. Forget about this. You are running a code on your system. Okay. Let us say this is my computer. I'm running a code on my computer. Anything. Here I'm running my, for example, let's say this is my computer where I'm running my code. Now, my code will run on the memory of my computer. Yes or no? No, it will not need more computational resource. That is the beauty of asynchronous programming. Now, so let us say I have a computer, I run a code. Okay. If a code is running on whose CPU will it consume? If a code is running on my computer, whose CPU will it consume?
CPU only.
My computer one. Guys, what is, I mean, please answer. Don't sit idle, otherwise I'll close the session. I don't want to like talk to wall, please. So now, suppose what happens in your code, you are making an API call to a server. Okay, let's say this is a website where you are making some API call. Okay. Now, so the result of your program. So you're making an API call here, for example. Let us say. Now tell me the execution of the whole program where you run your code. Inside the code, there is some API call. Once API call gets completed, then it comes back to your computer and you get the result. Now in this whole process, can I say that it is not the success of the program is not dependent only on my computer. It is also dependent on this website which is responsible to provide the API response. If I get a faster API response, my code will run result faster. If I don't get a faster response, I will get the response little slower. Yes or no?
Yes.
Yes.
Now, suppose your code started. Let's say your code started here. This is your code lines. Okay. Now, in those code lines, there is some API call. So when API call is happening, is your computer's memory being consumed? Let us say you send a request from this computer to website. Now website is handling the API call. Is your computer doing any task right now?
Yes, it's
No.
what is the function is giving the API call.
Sorry?
It's allocating memory to the destination with
Please come in front of mic, then speak, right? Your voice is not clear. Tell me this thing. If when computer sends an API request, this API is being handled by the website. So is computer doing anything right now? Apart from waiting?
No.
No.
It is not doing anything. So the memory of my computer is available.
Yes.
Correct? So now let us say this particular task takes 20 seconds to run. This API call takes 20 seconds. Now for those 20 seconds, do you want your computer to sit idle or you want it to work something?
If it works, it will efficiently make our program.
What I'm asking, answer me that. For these 20 seconds,
We wanted to get on work.
you want to what?
The computer in idle time, it should work.
It should work.
Yeah.
Think this example which I was showing. This example where I was showing the waiter one. Waiter took the order, gave to the cook. Cook is the API call right now. Meanwhile, cook is preparing the food. Waiter can get the order from B, get the order from C, and send it to the server, to the cook. Yes or no?
Yes.
Same thing has to happen here. When you write multiple lines of code, one below each other, okay, multiple functions, and those tasks which involve IO operations. So what are IO operations? They can be API call, okay. They can be database connection, okay. They can be sleep. They can be document reading or anything. There are like a lot of IO input output operations. So for those scenarios, when your computer is dependent on external thing to respond, right? There you bring the concept of asynchronous programming, that you don't want your computer to sit idle. You want that meanwhile it is waiting response from something external, it should start working. It should work on the remaining tasks that it has. So meanwhile it is waiting for the food of A, it should start taking the order from B and C and at least give to the cook so that their process can get started. Is it clear so far?
Yes, clear.
Now in this whole process, tell me, is there any increase in the memory of the power, basically the RAM of the computer? Let's say initially its RAM was 16 GB. Is there any increase in that?
No.
So what I'm trying to do here, what happens in asynchronous programming, you do not increase the memory. With the same memory, you just try that your computer does not sit idle.
It's allocating memory to the other processes while this process continues and blocking the memory.
Because while it is waiting for this result, it is not working anything. So it has got some free memory. It is using that memory to run the other task rather than sitting free. Clear? Yes or no?
Yes.
So the question over here. So only in input or output operations, asynchronous programming is helpful. We can't customize some in this concept into any other code of ours.
When now think it's not only about input. Think those scenarios when things are not running on your computer. Here API call is dependent on external service, right? That is why if this task was happening on this computer, then asynchronous programming will not result in anything beneficial.
Okay, got it.
So these operations, when you're dependent on some external services, these are called IO operations. So that is why it is only applicable in IO operations. When you basically share your work with some external thing. Okay, some of your task is being handled by external thing. There you use this concept of asynchronous programming. Okay. So the answer to your question, yes, it is only applicable to IO operations, because the whole concept is that you share the workload basically, right? Any question, anyone?
So I have a question actually.
Yeah.
Like here you took the example of waiter in this restaurant. Here it works, but sometimes in real life it happens that tasks are dependent, and like next logic have some prerequisites of the previous logic must be run. It might depend on the output of the previous logic. In that case,
In that case, async is not required.
Okay, it will not applicable, no?
It will be applicable, but it will not give you any time benefit, right? Your time will think logically, right? If your next operation is dependent upon the execution of the previous operation, then it will not save your time.
Yes.
That's what I'm saying. Async is used when
it doesn't make any sense to use the async.
Sorry?
I think in that case, it doesn't fulfill any objective. Use the async.
Yeah, in that case, it does not full, but there are a lot of scenarios when you do database connection, API calls and everything, right? So there you, instead of basically blocking your program, you wait for that result. Meanwhile, you start doing other tasks as well.
Got it.
Is it clear, everyone?
Yeah.
Yes, clear.
Okay. Now, how does this async programming do this? This does this using a concept called as event loop. Okay, which I'm going to explain you now.
Could you please repeat actually?
What?
What is the programming? Like I joined late, right?
When did you join?
I joined only 10 minutes back only.
So what you don't understand? Tell me.
Asynchronous programming, like just want to understand that high level.
So at the high level, asynchronous programming is when you have a code, basically when there are multiple operations going on one by one. Okay, and if you leave them, so there are two ways to do things. If you leave them as such that only after first gets finished, then only you start the other, then it will take more time. In asynchronous programming, what we do that meanwhile one is running, you start other as well. You start a third as well, so that overall it takes less time. That is the whole intuition of asynchronous programming.
So that means there is no dependency. No?
There is no dependency. Then only it is possible. Yes.
Okay.
Okay. So how does it work? I explained it works with this concept of IO operations. So only those scenarios when the memory is shared with some external services, there only it's applicable. If memory is not shared with external, think like this: you are making a GPT call, right? And it is taking 30 seconds to get the response. Meanwhile, you can do something else as well in your code, right? So that is what it will do. So how does it work? Basically, it works on the concept. There's a concept called as event loop. Okay. So let me explain you this particular part, which is very, very important. Event loop. Okay. So what happens in an event loop is that when you use asynchronous programming, suppose you have 4 tasks. Okay. And this is an event loop. So what will happen? So let's say this is task 1. Okay, so what happens that this you create different tasks which we will basically call them coroutines. Okay, you create different tasks in your code. Okay, and then you give to an event loop. Now what event loop will do, these tasks will keep on revolving around this event loop. Okay, this event loop will take any task at random or depending upon whichever is passed first. So let us say it takes task 3. Okay, and it will start executing the task this part. Now these task 1, task 4 are sitting idle right now. They are not being done. Now suppose here what happens, an IO, basically an API call or some connection comes. So what it does, it takes this and it puts it on rest. So this is called await. Okay, await means that right now some API call or something is going on. So hold this task. So pause this operation right now. Meanwhile, take the task 4. Okay, and it will start operating the task 4. Once the task 4 is finished, or maybe let us say it also goes into the await mode. Okay, it goes into the await mode. It will check is the operation for task 3 done. If it is done, it will pick it up and perform the result and share back. Or if both are still in await, it will pick the next task 2, and it will put in await, right? And in whatever order task starts getting completed, it will start pushing them out, that okay, done, this also done, this also done. This is how an event loop works. Any doubt?
No.
So do we give the sequence of how event loop should take?
Yes.
Okay.
You give the sequence. The order in which you define it becomes the sequence.
Okay, thank you.
Anyone, any question? Was it so easy, or you're not speaking anything?
So in the coding, how we define that event loop?
I'm coming there. Okay, so now let's move towards coding. Any doubt in the theoretical part so far? Okay, let's move to the coding part now. So first of all, what you have to do here, so how to use asyncio is you'll write down import asyncio. This is a pre-built library present inside Python. Okay, now the first step, remember, you have to define you have to use the word async in front of function. If you don't use async, it means it is not an asynchronous program. Okay, so what becomes very, very important is basically your start of your sync. So I'll say async, and I'll call a function def main. Okay, and let us say, what does this function do? It just print starting async program. Okay. So let us say this is a very basic function that I have created. I have just used async in front of it. Okay. Now, and pay very, very close attention here. Now, this function that you create with async, remember, this is a function, what you create. But what you create here is not a function. It is called a coroutine. Okay, very, very important. Coroutine. So when you add an async in front of a function, the function does not remain a function. Function becomes a coroutine. And in the event loop, which I showed you, you don't pass functions, you pass coroutines. That is the first thing. So what is coroutine? Coroutine is nothing. When you take a function, add async in front of it. That becomes a coroutine. Okay. Now, here, so again, I'll come to this little bit. Now, this is your coroutine. Now, what you have to do is you have to run this coroutine basically. So run the coroutine. So how to run it? You will say asyncio dot run, and inside this you have to pass coroutines, whatever coroutine you have created. So which coroutine? So there are multiple ways to run. Right now I'm showing you how to run one coroutine. Okay, so you will say main and this. So this is the name of my coroutine, right? I'll pass it here like a function, and now when I run it, it will give me starting async program. Is it clear so far?
Any function that will start with the word async, that is the coroutine.
That is a coroutine. Now, the key thing to remember here, like a function, when you use a function, how do you call a function? Suppose I create a function def main print hi. So how do you call this function?
Just the main in the function name.
You will say main, okay, and when you run it, it will give you hi. But it does not work here. Now try to see here. If I try to do it here, what will happen? If I try to say main, you would be expecting that it will run because it will run, but it will not run because this is not a function. It will give you an error. Coroutine main was never awaited. I will tell you what does it mean. Okay, and it will give you some error. This is a very, very important thing to run. You cannot run once you define async, it does not remain a function. It becomes a coroutine, and so it does not behave like a function. You will have to, there are specific ways on how you run a coroutine. That is the first part. Is it clear? Any doubt so far? Just few more minutes for the session, right? Just want to share a couple of scenarios. Then advanced class we will do in the main course only, but yeah. Any doubt, anyone? Now try to see this. If I say print main, what does it show? Let's see. It shows me coroutine object main at this. Okay. So what does this become? This becomes a coroutine main. It does not remain a function. That is the very, very important thing. And you get this error, coroutine main was never awaited. So how to basically run it? You have to await it. Now there is a thing called as await in so in an event loop, when you run it, you take a coroutine and you await it, and then only it will run. So let me show you an example. So what I'm going to do here is let me see. Okay. So let's keep a simple example. I would say is async def. Okay, I'll say fetch underscore data. Okay, and let's say delay. I'll be adding some delay here. So I will say print fetching data. Okay, and I will say this. Now I'll say await. Now this is very, very important. Await asyncio dot sleep or delay. So what does this await means? This await means if you don't use await, so coroutine, when you take a function, you convert, you add async in front of it, it becomes a coroutine. Now, so this is a coroutine, right? What we have created. Now you have to await it. Await means that it becomes something that this event loop can pause. So by await, you mean that I can pause this function. So what does it mean? That meanwhile, this particular code is sleeping for a certain second. Let's say it is sleeping for 10 seconds. I can pause this function and I can do the remaining task. Getting my point? If you don't add await here, what will it mean? It will mean that this function cannot be paused. And if this function cannot be paused, means you cannot move to the next function. You will have to wait for the result of this function. But when you add await in front of any function or coroutine basically that you create, it means that this coroutine, what you created, is now in the await mode. That it is fetching some result somewhere. So I have paused it for a while. And meanwhile, I will move forward with the other task. Okay, so now I'll say print, let's say data fetched. Okay, and then I will say return. For example, you can return some dictionary, maybe data, and you can say random data. Okay, so you have returned some particular data with it. Now, so this is what this whole thing is what? Tell me. Fetch data is a function or it is a coroutine?
Coroutine.
So if I have to invoke, so now see this. If I run this fetch data, and let's say I add a delay of 5 seconds, will it run or give me an error?
It will run.
It will give me an error.
What?
Will it run or it will give me an error?
It will run, right? But it will wait for a 5 seconds and give the output.
It will not run.
Why?
What did I show you in the previous example?
Because it's not a normal function
not
and
a
you can't
function
call
anymore.
it.
When you have a function, then you use a function like this. Is this a function or it is what?
Coroutine.
If I run this, it will give me an error. Coroutine fetch data was never awaited. So it will not run. This is what I want to tell you. Had it been this, wait a second. Then you don't, wait a second. So had it been something like this, def, so let me just copy it. Had it been like def fetch data delay, forget it.
So this becomes the normal function, right?
Yeah, and if I say fetch underscore data
5 seconds.
anything, right? Now if I run this, it will give me the result, right? Because this is a normal function. But what I have created is a coroutine. So you have to await the coroutine. So remember, asyncio.sleep is also coroutine. This sleep is also coroutine. Okay. So by default, it's using this now. So what you have to do, you have to await it. Now to do that, you have to define another coroutine inside which you can call this. So let me show you what does it mean. I will say async def name. Okay. Now I'll say print start of the main coroutine. Okay. Now here, what will happen? You will say task is equal to fetch. You're calling this function fetch data, and let us say you're passing 2 seconds. Now tell me that when I'm calling this function, will it run here at this point of time? What do you think?
Can you please repeat the
I'm asking,
question?
if I'm running this code, will it run? Will this particular thing start this function?
No.
I'm saying fetch data for 2 seconds. So will it start this code if I run this?
In normal scenario, it should not run.
It should come under await.
In normal scenario, it will run. But what is fetch data?
No, I mean, it's a coroutine.
Coroutine. So to
Yeah,
run
it
a
should not
coroutine,
work, but
what do you
I
need?
don't know if we are placing it inside another coroutine.
Yeah, we are placing it inside another coroutine, that works. But to run a coroutine, you need to what?
Asyncio.run.
You need to await it.
Await. Okay.
Okay. So you need to say await. Okay. Or you can simply say something like this: result is equal to await, and then you call this fetch data 2. Okay. Or you can simply call this task. So at this step, this execution will not start. So if I think like this, if I do print check, okay, before check, this thing will not start. So think like this: if fetch data has to start before check, can I say that this fetching data and data fetched will print before check?
Yeah, if it starts before check.
If fetch data runs before check, before this line, it means all these 2 print statements will come before it. And if it runs after check, it will come after check, basically, right?
Yeah.
Okay, so we will see that in the result. Now, I'll say, so once this is done, I'll say print received result. Okay. And I'll say, again, basically market result. And then I will say print end of the main coroutine. Okay. Now, if you see these 2 codes, this is my first coroutine, correct? Yes or no?
Yes.
And this is my second coroutine. Now, this is a very, very important line. You cannot run a coroutine on itself. To run a coroutine, you have to use it inside another coroutine, and you have to await it. That is what we are doing here. This particular thing, we are not running randomly from here there. We are calling it inside another coroutine, and we are using this await. What does this await mean? Await means that meanwhile, suppose you have given sleep of 10 seconds. Meanwhile, let us say it is sleeping for 10 seconds. If there is any other coroutine present after this, it will pick that. Do you get it, or it is going above your head?
Yes, it will pause this function and go to that function. Next
Call
coroutine.
this function, wait for 10 seconds, and in those 10 seconds, it will start executing the other function or coroutine, basically. Okay. Now, to run this.
Only other coroutine or any other function as well?
coroutine, not function. Now I will run the.
So here we have two coroutines, right? One is fetch data and main, right?
Yeah.
So now I want to call, right? So how to call that?
Yeah. Now I will run this main using a method called asyncio. Okay. Dot run. Okay. And here you have to pass the coroutine. So what is my main coroutine? Main. Correct. This is how you will run it. Through inside this main, you're calling the other coroutine, so you don't need to pass it here.
So in this way, we can call the fetch also, right? Suppose main is not there. So asynchronous dot run and fetch data, right?
Yeah, you can call that as well.
Oh.
I'll show you. So for example, let us say I say fetch, and let us say 2 seconds. Okay. Sorry, what is its name? Fetch data. Right. Fetching data, data fetched. It worked, right? Do you see this? Yes or no?
Yes.
So now I will try to call. This is the last topic, guys. I am not extending up. There are a lot of topics remaining, but it will be too much if I explain you a lot of things. So there is asyncio.gather, where you run 100 coroutines, you optimize the performance, and a lot of things are there. This is just an introduction class. Okay. So now when you do this main, what will happen? Now remember, make sure this check should run before this fetch data. Yes or no? So if I run this now, see, start of the main. So it first gave this start of the main coroutine, then it gave check, and after only it said fetching data. Does it make sense?
Yes.
Okay. So this is about it, right? This is the introduction to async programming, where what you do, you write multiple codes, you reduce their time, right? Remember I showed you in the first example that you write multiple codes and you use async, and their overall performance is reduced. Now this is a very, very big topic, async programming. This is a very much, like, this is not even like 1% whatever I've told you. Okay. So I mean, remaining I will cover in the course only, but just wanted to give an introduction. Go read about it. This is very, 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 very much required when you do your production grade codes. You will see everywhere people writing this thing, async await, async await. If you don't trust me, Google it. You will see it, right? So it becomes very important to understand. So that's it from my end in this session. Not extending beyond this, right? This video will be uploaded on YouTube. You can revise from there, but this is just an introduction. Go read about it and try if you can watch some good video and try to learn the concept. Okay.
Sir, we use this topic in databases, right?
You using databases, API call, web scraping. Mainly used there. In web scraping, a lot of times you have to read from 100 pages, right? So for example, let me show you a very simple example. LangChain web scraping. Okay. So there is see, you will see this async programming with LangChain, right? You see this await, right? And a lot of examples you will see. that mostly it is used in when you do web scraping and all those things. There it is.
But I think it is in documentation. I have seen it.
Yeah, I've also seen it. I'm also not able to recall. See, here also they have shown using async for doc in lazy load, right? So when you do multiple, remember, web scraping, API calls, your database connection requests, right? These are some of the most common examples where you need async programming. Okay, so see this here also they're using it. So you need to understand how does it work. Not a very complex task, but if you understand it once, it will be easy because you'll have to write in your codes. So now a very simple example use case I will tell you, which I was working in my company, was that what we were doing, we were taking customers, so not customers, like people were uploading their product documentation and they were asking some recommendation based on that. Now what was happening that meanwhile, if a person uploads multiple documents, right, it took a lot of time to process that. And once we incorporated the async programming, same process took even like reduced by 1/10, like reduced to 1/10 and all those things, right? So this is very, very important.
It was about drag, I guess, right? Multiple document and then the processing on it.
Yes, yes, yes. So it is there. Do read about this topic, very, very important, right? If you guys have any other question, please feel free to ask. Otherwise, you can enjoy your weekend. I won't take more time. How important data and OR? What is OR? I didn't get. It is there required. I mean, it is required there. I mean, data and all those things. It's very, very important. Async programming is like a part of prescriptive analytics. It will be required there. I mean, I need to see the scenario, but it's a very common thing, async programming. Right? So. Any other question? Anyone? Okay, thank you guys. Enjoy your weekend. Have a good day. And we will see you in the morning class of Python. I mean, your evening, my morning. Yeah.